Alright, geometry students, this is worksheet number 3, interior and exterior angles of convex polygons, and these are some video hints. So your first helpful hint is go ahead and put on your name, because of course you would want to make sure that you get full credit for this assignment, and you can't do that if you don't put your name on. Alright, so we're talking here about convex polygons, and you might remember from your previous section, convex polygons are ones that do not have any indents. So for instance, this might be an example of a convex polygon, whereas a non-convex polygon might look like that. It's the indent here that makes it non-convex. Okay, so we're going to move on, and we're talking about the measures of angles specifically. And so we've got two different types we're talking about, interior angles and exterior angles. The interior angles in my diagram here are angles 1, 2, 3, 4, and 5. So looking at my diagram, those are going to be my angles here. 1, 2, 3, 4, and 5. Notice it's just the ones on the inside. The exterior angles, on the other hand, are going to be the ones that are supplementary to those interior angles. So they're going to be the ones on the outside here, 10, 9, 8, 7, and 6. Right? So here, these are the exterior angles, the ones in red. And the ones in green are the interior angles. Okay? So make sure that you really are able to identify what each type of angle is. That's going to really make doing these problems and doing this packet much easier. All right, let's take a look at what they ask us to do first then. One other little helpful hint is that you'll notice up here that it tells you some materials you're going to need, and part of the materials you're going to need, or the only really materials besides this worksheet, are going to be a protractor. So make sure that you have a protractor ready for this next section. So here it says exterior angles of convex polygons. Remember, those are the ones that are on the outside. And it says there's an interesting property for the sum of the exterior angles, and that should be of polygons, not or polygons. Let's do some measurements. Let me just fix that up really quickly. So it says let's do some measurements to see if we can find out what that property is. And it says use a protractor, which we just talked about, to measure each exterior angle. And then we're going to add them up and round the answer to the nearest 10 degrees. And they ask, do you notice a pattern? So on this first one, this triangle, we'll do it together. So notice I had a starting triangle, but I added these lines here. And I'm adding those because, of course, if I want to measure the exterior angles, I need these lines to help me find them, because the exterior angles are going to be the ones that are here on the outside. So these are the three angles I want to measure. Okay? Now, I've already measured one of them for you, 124 degrees. So I want to go ahead and measure these other two angles, the ones on the outside. So let's grab my protractor. So here's my protractor. Now, when I put this over my other diagram, you can see it's going to block out my triangle, but it won't block out the lines that I made, that I extended from the sides of my triangle. So if I want to find this angle here, then I need to move my protractor over there, and I need to put this part of my protractor right on the vertex, and the base of my protractor has to go along one side or the other of the angle. So let's do that right now. All right, so I've got my protractor. Again, the base is along one side of my angle. And then I want to decide which of my scales to use. Because I start here at 0, I'm going to count up on the outside scale. And so I'm going to count up. Now, it's hard to tell exactly where that goes because my line doesn't go quite far enough. So I could either extend that using my ruler, or I could just take something like an index card and extend it up on the side there. So if I were to do that, so I'm using this as though it's an index card, and I'm extending it up, and you can see that it now looks like it goes up to 90, and then 1, 2, 3, 4, 5. So it looks like it's going to be a 95-degree angle, which I can write down here. So 95 degrees. Okay, I can do the same thing then and measure this angle. And when I do that, I'm just going to do that on a separate page. Why don't you try it right now? So pause the video and try measuring it, and then check back here to see if you get the same measurement. So the measurement I found was 140 degrees. So I found my 3 exterior angles. It makes sense. It's a 3-sided figure, so it's going to have 3 exterior angles. Now the next thing it said to do was to add them up. And then we're going to round the answer to the nearest 10 degrees. So let's do that. So I'm going to say the sum is equal to 124 plus 140 plus 95. And when I add those 3 together, I get 359 degrees. But of course it said round to the nearest 10, so that's closest to 360, right? It's closer, I want to round to the nearest 10, so either 350 or 360, and of course it's closer to 360 than 350. And I'm rounding because of course my measurements may not be totally exact. I might be off by a couple of degrees. So we want to do the same thing for each of these other figures. We want to do it for a quadrilateral, a pentagon, and a hexagon. I'll get you started on the quadrilateral. Again, the first thing we need to do is to create some extensions to show where the exterior angles are. So for instance, I might go along this side. I'm going to use my line tool here and extend this side out, and that'll create an angle right here. And then I can extend this side down this direction, and that gives me an exterior angle here. I can extend this side, whoops, wrong color. I can extend this side across this way. And then I'll do the fourth side will be here. And there's my 4th exterior angle. Okay? So that's one possible way to do it in order to be able to get those angles. The other possibility would be to do this. And you can see in this case, I simply made the measurements going around the other way. In either case, though, they're going to be the same measurement because, of course, the one I had before is simply going to be a vertical angle to this one, right? So these 2 angles will be the same regardless. Okay, so pause the video right now and finish off this page. Again, you should be finding some sort of very obvious pattern when you add up these numbers and find their sums. So if you're not seeing an obvious pattern, then it might be time to stop and ask for some help. Okay, on to the next page, worksheet 3A. So this is the next page. And we're talking now about the interior angles of a convex polygons. And so we're going to be using this idea of finding interior angles at various points throughout the year. And so a neat, easy way to do that is by using our knowledge of triangles. And so it says, start by answering this question. What is the sum of the interior angles of a triangle? Well, I certainly hope that you know what the answer to that is. So I'm not going to answer that part for you. On the second part, though, it teaches us the method. And so it says, for every convex polygon, we can cut into a series of triangles by drawing in the diagonals, and we're trying to make as few triangles as possible. That's an important piece. And then you can follow this example. So notice on step 2, we cut into as few triangles as possible, and the best way to do that is to draw all the diagonals from one vertex. So in this example, I went to this vertex, and then drew the 2 diagonals. Those are the only 2 diagonals because, of course, this is a side, and this is a side, and I can't draw a segment to itself. So in that case, I have 3 triangles, and each one has 180 degrees, and so therefore the sum is going to be 3 times 180. And the reason for that is you can see here that the angles of the triangle, so if I mark all the angles of each triangle, those end up being the interior angles of my polygon. All right, so let's take a look at some examples now of how we can use this. So for the first one, the triangle, there's only one triangle in a triangle, of course, and so therefore the sum of the interior angles is simply 180 degrees. For this next one, it's got 4 sides, so go ahead and write down the name for it. And you can see that I've already divided it. This can be divided into just 2 triangles. That's the smallest number of triangles I can make, and each one is going to have 180 degrees. So therefore the sum of these angles is going to be 2 times 180, because there are 2 triangles, and therefore the sum of the interior angles for this figure, again, whose name you still need to write, is going to be 360 degrees. So pause the video right now and go ahead and find the name and the sum of the interior angles for each of these other diagrams. So on this next worksheet, worksheet number 3B, it's talking about the interior and exterior angles, and we're going to start making a table to see if we can find the patterns that are going on here. So for instance, and make sure you read all of this information, it's all really important, especially these parts. Okay? But I'm going to start helping you fill in the table. So triangle is our first one. It says the number of sides, of course, is simply 3. And the number of triangles in a triangle, well, looking back, I can see there's only 1 triangle. So I would put 1 for that. The sum of the interior angles, again, I can look back here, and I see the sum of the interior angles is simply 180 degrees. So I'll put 180 here, degrees. And the sum of the exterior angles for a triangle was simply 360 degrees. And so I can put this right here. Okay, so for this next one, the quadrilateral, that's a 4-sided figure, right? And we found for the 4-sided figure, so this will be 4, the number of triangles that we can make, we can see it was 2, right? 1 triangle here, 1 triangle there. The sum of the interior angles you haven't found yet, oh, actually we did find that, that was 360 degrees, so we can add that to our table. And we have not gotten as far as finding the sum of the exterior angles. At least I didn't do that. You should have done that, though, back on this page. So whatever sum you found here for the quadrilateral should now go into your table. Okay? So finish filling out the rest of your table right now. And then, if you can see what a pattern is going on here between these things, or along here, see if you can find some way to extend this polygon or this pattern to go to a 20gon. So let's clean up our diagram here a little bit. So for instance, maybe you notice there's a pattern between the number of sides and how many triangles there are. The number of sides and how many triangles. Maybe you can use that to help you figure out how many triangles a 20gon will have without actually having to draw it. And of course, once we have the number of triangles, we know how to find the angles based on that each triangle has 180 degrees. Okay? One thing that it says here that might be helpful is to remember that an n-gon has n sides. So the number of sides here is simply going to be n. Alright, go ahead and try to fill in the rest of this information on your own. If you get really stuck, then it might be time to ask Mr. Lizzie for some help. Looking a little bit lower on our sheet here, it says, using the information from our questions that were just above, we can write the following formulas for any convex polygon, where we use n to stand for the number of sides. And of course, we're going to want to copy these formulas into our notebook. I'll give you a hint. These are going to come right from the answers that we end up putting in here. Okay? So again, this is why we're trying to find the patterns here. You should find a pattern that belongs to all of the sum of the exterior angles that can help you fill in this bottom part. And you should have found a pattern going across to each of these that will help us figure out a formula here. So these two formulas, 1 and 2, whatever those formulas are going to be the things that go here. Of course, they're not actually 1 and 2, it's just the pieces that go there. Okay? Now, with regular polygons, we know they're both equiangular and equilateral. So all the angles in a regular polygon must have the same measure. So if we know the sum of the interior angles and the number of angles, we can find out what each angle measures. And we can do that simply by splitting them up. So if we have a pentagon, it's got 5 sides, and if the sum of the interior angles is 540, and it has 5 angles, we can simply find the measure of each interior angle by taking the total, 540, and dividing by 5, which gives us 180. So now we want to go ahead and finish the formulas for regular polygons with n sides. For each interior angle, this is the sum of the interior angles, and then we're dividing it by the number of sides. And again, an n-gon has n sides. For each exterior angle, we're starting with the sum of the exterior angles and dividing by the number of sides. Again, it has n sides. So see if you can finish those formulas on your own. If you're having trouble with these, again, it may be time to come and get some help from Mr. Livesey during class. All right, so here's some examples where we use our formulas from the previous page to solve each of the following examples. So we look at the examples first and then try the other one on your own. So the example says, find the sum of the interior angles. So sum of the interior angles for a heptagon. A heptagon has 7 sides, so I know n equals 7. And we're going to use our sum of interior angles formula, which you should have found on the previous page to be this. The sum of the interior angles equals 180 times n minus 2. So if n is 7, I simply plug in the 7 here, and then solve down, and so I find 900. So our next thing to do then is to find the sum of the interior angles for an octagon. So we're going to use the same formula, but of course n will be different for an octagon. So pause the video right now and try this problem on your own. Okay, these next two examples are very similar. So it says find the measure of each interior angle for a regular octagon. And so I'm using the each interior angle formula and then plugging in my n of 8. So follow this one through, see how this one got solved, and then try applying that for a regular decagon. For this third example, it says find the measure of each exterior angle. And so we're going to use our each exterior angle formula, which is just this. And because it's a triangle, we know that n equals 3. And so therefore, I can just plug in 3 for n. Notice in this case, I did not say a regular triangle, I just said equilateral. But of course, an equilateral triangle must also be equiangular and therefore is regular. And so this still works for my regular polygon formulas. All right, pause the video and try doing an example for a nonagon. Now on the back side, or the last sheet rather, in some cases we start knowing what each interior or exterior angle is for a regular polygon, and then we have to work backwards to find the number of sides. So we're going to be using the same formulas we just used, but we're going to be using them in a different way. So for our first example here, it says find the number of sides in a regular polygon that has interior angles that each measure 60 degrees. So it's telling us that each interior angle, right, each interior angle measures 60 degrees, which means I'm going to use the each interior angle formula, which is this one. But instead of giving us the n, they're actually giving us the each interior angle. So I'm going to take my 60 degrees and put it right in there, which gives me 60 equals my formula, 180 times n minus 2 over n. Now I want to solve for n, but right now there is a problem because the n is the denominator. And so I can deal with that, and you may want to add this to your notes, by multiplying both sides by n. When I do that, the n's cancel here and here, and so I'm left with 60n equals 180n minus 2. I still want to get the n's together, so my next step is to distribute the 180 to both of these. And so therefore I get 60n equals 180n minus 360. Now I got a little tricky here. I actually moved the 360 and the 360 by adding to both sides and subtracting the 60. That's how I got the 120n equals 360. If that's a little confusing, I also simply could have subtracted 180n from both sides. And that would have given me a negative 120 and a negative 360. And then when I divide both sides by negative 120, I'll still end up with an answer of n equals 3. And because n stands for the number of sides, the polygon must be a triangle. All right, pause the video right now and try this example. So you're trying to find a regular polygon where the interior angles each measure 140 degrees. So pause the video and try this on your own. So this last one is very similar to what we just did, except we're talking about exterior angles. So we're going to use our each exterior angle formula. And we know that each exterior angle for a regular polygon is equal to 360 divided by the number of sides n. So if each exterior angle measures 60, that goes right in here. And so I'm get 60 equals 360 over n. Again, I can multiply both sides by n, so you can add these to your notes if you would like, which gives me 60n equals 360. And then I can simply divide both sides by 60, and I'll find that n equals 6. Therefore, the polygon has 6 sides and is therefore a hexagon. So that's the end of the video, folks. Go ahead and try that same process to find the polygon that has exterior angles, or the regular polygon that has exterior angles that measure 36 degrees. And if you need additional help, I'll see you in class tomorrow. Good luck.